Have you ever stopped and wondered how a website with an absolutely insane amount of traffic actually works? You know, behind the scenes. Well, today we're going to break down the system architecture of one of the world's most visited sites, all from a developer's point of view. Let's dive right in. So, just to give you an idea of the sheer scale we're dealing with, get this. The site handles 80,000 views every single minute. The engineering challenge just to keep the lights on with that kind of traffic is it's immense. And if that first number wasn't crazy enough, what do those 80,000 views translate to? It means that over 11,000 hours of content are being watched at the exact same time every minute of every day. That's not just a lot of data, that is a constant, massive fire hose of traffic. So how on earth is this even possible, right? Well, it's definitely complex, but we can actually break it all down by looking at two fundamental journeys. First, there's the creator side, how they get their video onto the platform. And second, there's the watcher side, how you get that video on your screen instantly. Okay, so let's start with that first journey, the creator's upload. This whole process is about taking a single video file from one person and getting it ready to be streamed by millions of people all over the world. This journey follows a really clear logical path. It all starts with verification, then moves on to the actual file upload. After that, it hits a super important step called queuing before it finally gets transcoded. So let's break down what each of these really means. First up, verification. Now, this isn't like other platforms where you just sign up and start uploading. Here, there's a mandatory Know Your Customer, or KYC process. It's a critical identity check that's required for creators, and that makes the starting point here very, very different. So once a creator is verified, they can finally upload their stuff. The video file itself, plus all the metadata, the title, the description, it all gets sent to this giant digital storage container, which developers usually call a bucket. It's a lot like something you'd see with Amazon S3. Okay, this is where things get really smart. It's all about this idea of decoupling. You see, you can't have the upload service talk directly to the video processing service. Why not? Well, imagine 20,000 videos getting uploaded at the same time. The whole system would just crash. So instead, every upload gets added to a queue. It's basically like lining up for coffee. This keeps the two systems separate and prevents a total meltdown. So what happens when a video gets to the front of that line? It gets transcoded. And this is the real behind-the-scenes magic. A special service grabs that original file, no matter what format it's in, and it converts it into a whole bunch of standard formats and qualities. We're talking everything from 240p all the way up to 4K. And this is what guarantees it'll play perfectly, whether you're on your phone, your laptop, or your smart TV. And there you have it, the final step in the creator's journey. Once all that transcoding is finished, all those shiny new standardized video files get saved to a totally different storage bucket. They're now processed, they're optimized, and they are officially ready for an audience. All right, now let's flip the coin and look at the other side of the equation, the watcher's request. How does a video get from that storage bucket all the way to your screen in what feels like a fraction of a second? So you click play. We know the video is sitting right there in that storage bucket we just talked about. I mean, it seems logical to just stream it straight from there, doesn't it? Well, for a site operating at this kind of scale, that would be a complete and utter disaster. And here's exactly why that would be a disaster. If every single person was streaming from one central server in, say, Virginia, users in Japan or Australia would have terrible lag. The server would get totally overwhelmed, and you'd be stuck staring at that dreaded buffering wheel. The solution? A CDN, which spreads the load and gives you fast, smooth playback no matter where you are. So what exactly is a CDN? It stands for Content Delivery Network. Just think of it like a global web of servers, and all of them are holding copies of the most popular videos. So when you press play in London, you're not trying to grab that video from a server in California. Nope, you're getting it from a server that's maybe just down the road, which makes the delivery almost instantaneous. This all brings us to the final piece of the puzzle, the real secret sauce here. How do all these pieces actually work together to handle such a mind-boggling, massive scale of traffic? When you actually look at the individual components, the databases, the storage, the servers, none of it is really revolutionary tech. The source material is super clear on this. The tech stack is pretty standard stuff. The real engineering marvel isn't what they use, it's how they use it to manage that relentless, nonstop load. So the performance really boils down to three core pillars. We already talked about the CDN, but alongside that, the site relies on two other workhorses, aggressive caching and database replication. These three techniques, all working together, are what keep the entire system from just falling over. So let's quickly break those down. Caching, on the left, is all about keeping data that's accessed all the time, like the info for a trending video, in super fast memory. This means the system doesn't have to do a slow lookup to the main database. And then on the right, you have database replication. Instead of one database trying to handle millions of requests, you have a master database that writes new data and a bunch of replicas that just handle reading it. This spreads out the load and prevents a single point of failure. And really, this quote from the developer who analyzed the whole system, it just says it all. The design might look pretty simple on a whiteboard, but making it actually perform for millions of people at the same time is an incredibly complex challenge. It's all about performance at scale. So the individual parts are simple, but the execution at a global scale is nothing short of genius. It really leaves me with one final question for you. What other simple systems that we all use every single day, like a search engine or a social media feed, are actually incredible engineering marvels when you stop and consider the millions of users they have to serve every single second?